Hello everyone! In our previous video, we introduced the importance of nuclear energy, specifically how it is one of the safest energy sources. We also introduced historical accidents and concepts of nuclear safety, risk assessment, and risk management. Today we will focus on nuclear safety, which touches on a variety of different topics such as hardware, people, procedures, cultures, and regulation. All of these are aimed at keeping radioactive material inside robust barriers. Imagine radiation like a bad-smelling perfume, safe when the bottle stays sealed on the shelf, but if several stoppers fail at once, that scent can spread everywhere, lingering in the air, settling on clothes and food, bothering people's health and driving them away, and leaving a tough cleanup job behind. Keeping that perfume bottle sealed takes more than sturdy walls. It's a whole safety team. Engineers design many layers of safety systems, known as defense in depth, and analysts run probabilistic risk assessments to test millions of what-if scenarios. Operators monitor instruments around the clock, regulators set strict rules, and everyone practices clear step-by-step emergency drills. In this video, we'll journey through the three most infamous nuclear accidents: 3 Mile Island, Chernobyl, and Fukushima, to see what went wrong, what happened afterward, and how each disaster sparked the safety upgrades that make today's nuclear power plants strong and safe. In 1979, at 3 Mile Island near Harrisburg, Pennsylvania, a stuck valve and confusing gauges combined with operator error resulted in inadequate cooling water circulation, leading to the overheating of the reactor. The reactor core partly melted, but was contained by the thick steel shell surrounding it. People nearby received radiation equivalent to about one chest X-ray. About 140,000 residents evacuated for a few days as a precaution measure. Despite no cases of radiation illness being reported, the 12-year cleanup effort ended up costing around $1 billion. Lessons learned from this accident led to the implementation of stricter safety regulations for every nuclear reactor in the United States. This incident also significantly eroded public confidence in nuclear safety. In 1986, at Chernobyl, Ukraine, a risky late-night test on a Soviet-designed reactor with safety systems switched off caused its nuclear power to surge instead of drop. The resulting explosion blew the roof off Reactor 4. It's important to note that reactors of the Chernobyl design have never been used in the United States or in any other countries outside the Soviet Union. In addition, this reactor lacked a containment unit, which is an important protective feature used in all power reactors in the US. As a result of the explosion, a radioactive cloud drifted across Europe, forcing more than 1,300,000 people from their homes and causing over 6,000 childhood thyroid cancer cases. It also left an exclusion zone larger than the area of 3 New York cities, a region that remains largely empty today, while cleanup costs run into the tens of billions. The shock prompted countries to establish global safety standards such as the IAEA's Convention on Nuclear Safety, and transformed safety culture into a fundamental principle for every reactor. In March 2011, a severe and unlikely tsunami triggered by a record-breaking earthquake flooded Fukushima Daiichi's backup generators, leading 3 reactor cores to overheat and vent radioactive material into the air and sea. No one died from radiation, but the Japanese government ordered a precautionary evacuation of thousands of residents. Radiation doses outside the plant remained low, typically comparable to a chest X-ray for most evacuees. Yet the accident's economic aftershock talks approximately US $190 billion for cleanup, compensation, reconstruction, while seafood bans and stigma still ripple through local industries. Nuclear safety has evolved through an ongoing mix of research, day-to-day operating experience, and the lessons from rare accidents, each factor contributing to a culture of continuous improvement. So, what's the big picture? Nuclear safety is never finished. It's a living checklist that grows with every lesson learned. Engineers keep running new what-if tests, regulators keep tightening rules, and plant crews keep practicing drills because even the smallest improvement can block the next chain of errors. That consistent learning loop is what lets today's reactors make clean power while keeping that invisible perfume safely bottled up. And that's a wrap for today! In our next video, we'll dive into nuclear risk assessment and see how scientists and engineers keep pushing reactor safety to the next level. Stay curious, and I'll see you then!